Welcome to the next installment of this Unreal Engine 5 tutorial series where we create a smart enemy AI system inspired by the Xenomorph AI from Alien Isolation. In this week's lesson, because we'll be covering three very distinct topics, I've decided to split them up into three separate videos and release them all together. In part 6, we'll be doing some code cleanup, making our code more efficient, and making some minor performance improvements. In part 7, we'll be implementing prediction sense into our enemy AI. And in part 8, we'll be expanding upon our vision system by implementing multiple vision cones into our alien character in the same style as Alien Isolation. All three episodes are available to watch now, but just ensure that you follow each lesson in order, as each lesson builds upon changes from the last. As always, if you like the content, please like the video and consider subscribing to the channel. And with that out of the way, let's begin with part 7. Prediction sense. So let's first understand prediction sense by understanding the problem that it solves. Currently, when our alien loses sight of our player character, then we retrieve a reference to the player's last known location, but this last known location doesn't tell the alien anything about the direction the player is heading. In the real world, when we see someone running behind a wall, we no longer see them, but we understand which way they were going when they disappeared from our sight. Prediction sense in Unreal Engine attempts to provide the same information by providing a predicted location based on the direction and speed of the perceived actor. This will result in behavior that appears more intelligent and threatening. So let's go ahead and add the prediction sense to our AI perception component. We'll go to our content drawer, shoot content, blueprints, AI, alien, and we'll open up our AI controller. And then we'll select our AI perception component. And then under sensors config, we have already the AI sight config. We're going to add another sense. And this time it's going to be AI prediction sense. And now that we've got more than one sense active, let's go ahead and set a dominant sense as well. We will set the dominant sense to AI sense sight. Now we can also open up the information for this sense config. And there's not a whole lot that we need to worry about. The only thing we're going to need to change is our max age, and we will change this to 5 seconds. We'll go ahead and compile and save that. And now to implement a prediction event, we will open up our evaluate perception evaluator. And inside our handle sight stimulus function, if you recall, we have the handle target lost sight function. We'll double click that. And for now, what I will do is I will delete all of this information after the can see target variable, because we will be setting up a new function that will handle prediction. But once the alien has lost sight of our player character, we're going to right click and type in request pawn prediction event. And then we'll hook that up. Now in the request pawn prediction event, we have the requester, that is the agent that is requesting the prediction. In this case, it will be the alien character. So we'll get a copy of our alien character reference, and at the moment it seems like show inherited variables is disabled for some reason, so I'll just re-enable that, and then select context and drag out a reference to our alien character and hook that up to requester. And the predicted actor, in this case, will be our acquired target. So we'll drag out a reference to our acquired target, which is under the output category, and hook that up like so. Now the prediction time is how far out into the future we are projecting the predicted location. So for example, if we set this to 1 second, it will create a predicted location of our acquired target based on the direction that they're traveling, and projecting that 1 second into the future based on their direction of travel. We do want to keep this relatively small, because if we set it too large, then the predicted location will go too far out into the distance. For now, we'll set this at a value of 1 second. And now that we've requested a pawn prediction event, we will handle our prediction sense in a new function. So we'll add a function and call this handle prediction stimulus. Similar to last time, we will get a reference to our received stimulus and get sense class for stimulus. We will check to see if that is equal to AI sense prediction, and then create a branch. And if that returns true, we're going to set the predicted location of our target. And for that, I'm going to rename our last known target location variable, and we will call this predicted target location. Then we will set the predicted target location from the received stimulus, and then we will break that stimulus and then get the stimulus location. And then we will hide connected pins. And then once we've set our predicted target location, we'll update the alien's motivation. So we'll get the motivation param, get property reference. We'll get our set by ref node, hook it up like so, and then we'll change our motivation to alien motivation attack, try find target. Go back to our event graph, and then we will drag our function onto the event graph and hook this up like so. Then we compile and save. And now if we go into our level, we'll create an obstacle for our player character to run behind. I'm just going to go to the Place Actors window, which you can find under Window and then Place Actors. I'll select Shapes, and then I'll drag out a cube onto the world. And we'll scale this up a bit. Just keep a basic shape for now. And we'll just scale this out a little bit like so. And then when we press play, hit the tab key, hit the quotation marks key, we'll enter our enemy's line of sight, and then you'll see a predicted location is updating in real time. And this predicted location is calculated based on the speed and the direction in which the player character is moving. Now, I have noticed occasionally that the alien appears to fail at achieving the move to task at times, and then when it fails, it gets stuck in its state. And that's because if we go back to the state tree and go down to move to last known location, when we transition from move to last known location to our wait state, this transition rule is based on whether or not the state is completed. But sometimes what's happening is that this state is failing to complete. So what we could do is add in a new transition rule. And this time we could select on state failed and then select move to next state as well. So if this state is completed, it will move to the next state. But if it fails, it will still move to the next state. And one final thing we might do is change the name of this state to, we select the state and change the name to move to predicted location. Compile and save. Now, if you wanted to make adjustments to this prediction event, you could change the prediction time. So if we go back to our, handle target lost sight function, we could change the prediction time. So if you wanted it to predict further out into the future, I'll show you an example. If we change this to 5 seconds, and then compile and save, you'll notice that the predicted location is much further away now. And that's because it's predicting 5 seconds out into the future based on the trajectory and the speed of the target actor. Alternatively, we could make this a bit more of a tighter prediction. So we could change it to 0.5 seconds. Let's see what that result gives us. And that's a much closer, much tighter predicted location. But I quite like the value of 1 second. So we will leave the prediction time at a value of 1 second. So there you have it. Prediction sense is quite straightforward and fairly easy to implement. In the next video, which is available to watch now, we will expand the alien's vision sense by adding in multiple vision cones in the same style as the alien isolation game. Look forward to seeing you in the next lesson. The project files for these lessons are available to download from Gumroad completely for free, but if you would like to support the work that I do, please consider making a donation via the Buy Me a Coffee link in the video description, or by adding a monetary amount in the Gumroad link if you choose to download the project files. And a very special thank you to the people who have already supported this channel. Your support means a lot.